whatever the type of concentration we will see, whether it is molarity, whether it is strength, whether it is molality, whether it is weight by volume, whatever the thing is this, but the main aim of concentration is to tell the relative amount and solvent is taken in large amount. So as you can see that in the solution we have solute as well as solvent. That means we have more than one compound. Okay. To understand any solution, okay, we have a specific term that is known as concentration. Whatever the type of concentration we will see, whether it is molarity, whether it is strength, whether it is molality, whether it is weight by volume, whatever the thing is this, but the main aim of concentration is to tell the relative amount of solute with respect to solvent. Now here you should note not only to solvent but it can be solution also. We will see like in molarity we will be paying attention to the relativity of solution, but in molality we will see that thing called solvent. Okay. So basically the concentration terms, mainly the concentration terms which we will be studying is the molarity, and molarity is actually defined by moles of solute that I have written with the N upon volume of solution in liter, that is molarity. When I discuss about molality, so molality is the number of moles of the solute upon the weight of solvent, okay, weight of solvent only in kg. Now, one thing more, can you tell me that which one, molarity or molality, will be the temperature dependent? So, basically, we need to understand that mass or the weight which we see here, the weight actually it's the mass of, okay. So, that mass is temperature independent. So, this becomes temperature independent, but this molarity is temperature dependent. The third type of concentration term which we encounter is actually the strength. In this we will see that it is actually the weight of solute which we will measure in gram upon volume of solution in liter. That is the strength. Again here we are encountering the term of volume. So wherever you see volume, you understand that this will be temperature dependent. So yeah, this will become temperature dependent, right? The next term which you will be encountering is ppm. The meaning lies in the term itself. If you observe it carefully, ppm is actually parts per million. Okay. Million is what? Million is 10 raised to the power 6. You remember the number system of your class 3rd? Yeah, million is from international system and it's 10 raised to the power 6. So, the formula is weight of solute upon weight of solution into 10 raised to the power 6, that is parts per million, right? One more thing, not one more thing, yeah, a lot of things are there. So now we will see the percentages. In the percentages, we will see actually in total 3 percentages. Weight by weight, volume by volume, weight by volume. Now we need to see that which thing is which thing. So in all of the things above side, this is of solute. In weight by weight, it is the solution. Here in the volume, again it is the solution. Here in the volume, again it is the solution. Okay? Into 100. Right? One more thing I would like to tell, that density is what? Density is mass by volume, or here as it is chemistry, it is not your physics that we have to define the main difference between weight and mass. So yeah, we can write weight by volume. And here, as you know that volume is temperature dependent, so this density also becomes temperature dependent. Okay. Suppose there is a thing, or I should say that there is a solution basically, and it contains two components, A and B. Suppose if I want to find the mole fraction. So mole fraction of anything in chemistry in standard language, we write it as X. Okay, it is written as X, but it is pronounced as chi. Okay, so chi A is equal to number of moles of A, because we are finding the mole fraction of A upon the total moles, that is Na and Nb. Okay. Now for B, that is chi B, we can write Nb upon Na plus Nb. And as you know that this is a fraction. When we were in class 3rd, we were taught that whatever the fractions are there, proper fraction, okay. Fractions are of two types, proper fraction and improper fraction. Proper fraction is always less than 1, okay, and improper is more than 1 because numerator is greater, and then we express it in the form of mixed fraction. So yeah, here I am talking about the proper fraction. It is always less than 1. So the sum of the fraction of anything total, that is chi A plus chi B, it will be equal to 1. So this is also logical here in this case. Okay. Now, as a master line, I would like you people to write what you have seen. You have seen that wherever we were getting the term of volume, we were getting temperature dependency. So you can write that those concentration terms which has volume V in their formula are temperature dependent. Okay. Now, let us try to see some illustrations. Suppose if 2 moles of NaOH present in 1 liter of solution, find the molarity. What is molarity? Molarity is moles of solute, that is NaOH here, upon total volume of solution, that is V solution. What are the moles of NaOH? 2 moles. Upon what is the solution? What is the volume of solution? That is 1 liter. So molarity will become 2m, or m is also represented as mole per liter, right? Now let's proceed on to the second question.
Crowded classes, these gaps go unnoticed. With one-to-one mentoring, chemistry becomes logical and real improvement begins.